All right, guys, this is section 1.1, pre-algebra. We're going to begin by investigating some patterns. Analyzing sequences is the title of the section here. So some of our targets, name of the section is analyzing sequences, so we will analyze sequences. And then second part, we can describe patterns in simple sequences and give the next terms by using the pattern. So one example, just to kind of get going, back in the 19th and 20th century, there's a fictional character, Sherlock Holmes, known for his great detective work. So in order to solve these mysteries, Holmes used a deductive process that led him to a logical conclusion. And that's what this is all about. With sequences, you're kind of noticing a pattern and then trying to see if you can predict what would be the next steps in the pattern, what would be the next terms in the sequence is what it's going to be mathematically. Okay, so let's look at an example, the case of the Arabic numbers here. So at first glance, the picture down here, it seems to just give the numbers 1 through 9. However, the way they're drawn, right, they look a little different than if you were to just draw the numbers 1 through 9. You probably would not write them like this necessarily. But take a look at those. See if you can come up with anything about the way they're written that might form a sequence or kind of tie into the number itself. And it might not be obvious. But one thing as I was looking at these was I noticed, if you're thinking in terms of math especially, right, which we all should be doing, right, the number of angles formed. So for example, in the number 1, there's an angle formed there, right? There's one angle. In the number 2, we can see an angle there and an angle there, 2 angles being formed. Okay, in the number 3, there's an angle, there's an angle, and there's an angle, right? 3 angles being formed. Okay, even in the number 4, the way it's drawn, we could have an angle there, we could have a second angle, a third angle, and then a fourth angle. Okay, and so on. In the number 5, 1, 2, 3, 4, 5. Okay, so this is just kind of an example, and again, it's not an obvious thing. You might not notice it that way, but the way these are drawn, the number of angles formed is actually equal to the number itself. Okay, so if we were going to look at number 1, observe, analyze, and search for clues in the diagram to come up with a guess about why the numbers were first written this way, that might be it, right? We don't know for sure. I don't know if that's going to continue forever, but it kind of appears that way, at least in the numbers 1 through 9. Okay, so a couple definitions, some terms here that might be useful for us. Okay, on the left here, math terms. So a sequence is an ordered list of numbers or figures. Each number or figure of a sequence is called a term. Okay, so it's important. It's in order, right? You can't just have a group of things. It needs to be in a set order. Okay, and there's a couple types of sequences that you'll get into later on as you keep studying mathematics. There's actually a whole bunch, but 2 big ones was arithmetic sequence and then a geometric sequence. One involves addition or subtraction of a constant amount each time, while a geometric is more like multiplying by a constant amount each time. Okay, so let's discuss part A here. Describe the pattern you and your group noticed in the sequence. So as we share ideas, make sure we are presenting these clearly, okay? So I would say just basically on that previous problem we saw, it appeared that the number of angles formed was equal to the number. Right, so that was just kind of our idea. Part B introduces a new term here called a conjecture, and you can see the math term definition. So a conjecture is just a theory or an opinion, right? We're not going to prove that it's necessarily true. It's very difficult to prove things in mathematics sometimes. You have to prove something will work for every single case. So sometimes a conjecture is just a way, it's kind of like, almost like a hypothesis, kind of like an educated guess. But it's going to be formed without proof. So our conjecture might just be something that says like the number of angles formed is equal to the number. Sorry, I have not written with a stylus in a while, so I got to relearn that. Is equal to the number. The actual number of the figure, right? For example, the figure 1, we had 1 angle in it. The figure 2 had 2 angles in it, right? and so on. So let's take a look. Based on our conjecture, right? Based on our conclusion, can we explain how this pattern could also be described 0 with the symbol 0, right? And the symbol 0 in a circle, right? There's really no sharp edges or segments to form an angle, right? It's round. There is no angle. So that conjecture that we made seems to fit, right? The number of angles formed is 0 when the number is 0. All right, so now let's move on. The case of multiple viewpoints here. Let's think about this. So this case involves investigating the sequence shown below. So we see figure 1, figure 2, figure 3. In order to reconstruct the pattern and solve the mystery, several witnesses have been asked to describe the sequence. All right, so here we go. Witness 1, Bob, right? He says, I determined figure 1 is 25%, figure 2 is 50%, and figure 3 is 75%. Okay, is Bob right? So what do we think? Just at quick glance, does it look like 25% in figure 1, 50% in figure 2? So we can kind of think about the circle, right? If it was divided into 4, it's like a pie into 4 slices or whatever. Does it look like 25% figure 1? Yeah, 1 of the 4 pieces, right? Figure 2, 50%, 2 out of 4, 50%. Yep, and then figure 3, 3 out of 4. Okay, so it appears that he might be right? Just based on looking at the shaded region. Again, sorry about my handwriting. It will get better as we go on. I got to get used to this again. But yeah, the shaded region seems to represent that, doesn't it? Seems good to me. Okay, what about the second witness uses fractions, right? So let's see if we can kind of draw those in again. So we had figure 1, 2, 3. We had something like this, right? Shaded in that amount. I think figure 2 was like that. And figure 3 was something like this, right? So as fractions, again, if we think about the 4 pieces, right? Because that kind of looks like the size of the pieces. If we were thinking of this of a pie, it was kind of cut into fourths. As fractions, would we agree that is 1 of the 4? Okay, the second one was 2 of the 4, which we know can be reduced, right? Reducing fractions. Both numbers are divisible by 2. Okay, so 1/2 is equivalent. And then also over here, it was 3/4. Okay, and we had said previously as percentage, it was 25% is 1/4, right? 1/2 we know is 50%. Oh, we're not writing 73. And then 3/4 is, of course, 75%, right? There we go. Okay, so that seems like a good way to do this. All right, can I ask you guys now, what if someone came in, let's look at number 6, like Greg here. Greg believes the sequence is decreasing. Okay, the way we wrote it, right, 25%, 50%, 75% was definitely increasing. We kind of agreed with what Julie was saying, right? But imagine, what if, could someone come in and say that they think it's decreasing? Would they be wrong? Okay, here's the deal. Remember, this was called the differing viewpoints. Okay, what if we looked at the unshaded region? 3/4 on figure 1, 1/2 there, 1/4 there, right? Okay, then it could actually be considered a decreasing sequence. So it's really all about point of view. It depends. What are you focusing on, right? Are we looking at the shaded region, which is probably what most people, might assume, but it never said in the directions, right? We don't know for sure. So that's why we kind of need to be careful and make sure that we're clear and we know what we're talking about. And that everyone's kind of thinking of it the same way. Neither one's wrong, right? We just need some clarity and maybe a little more direction. Okay, and what do you guys think would happen? Let's take a look at number 7 here. Analyze the descriptions and draw figure 4. So figure 4 in the pattern, right? If 1 was 1/4, let's just draw our 4 pieces here. Right, figure 4 then, If it went from 1/4 to 2/4 to 3/4, figure 4 would have all 4/4 shaded in, right? So we would say that as a fraction, that would be 4/4, right? As a percentage, that could be thought of as 100%, right? That would be the next number if we went from 25 to 50 to 75, then to 100. But from the other perspective, from Greg's perspective, he thinks it's decreasing. It could be 0%, right? The amount that's not shaded. That's what Greg was kind of going with his point of view. Okay, so let's take a look here. We'll check our understanding and make sure we're on track here, and then do a little practice on our own. So take a second. Let's analyze the sequence below and see if we can answer items 8 and 9. All right, so draw the figure that we think is next in the sequence. So figure 4, we would have a square probably, right? Okay, and if we take a look at what's going on in the previous figures, I'm seeing one segment in figure 1, then I'm seeing 2 segments, then I'm seeing 1, 2, 3 segments. So I would probably think something like 1 segment, 2 segments, 3 segments, maybe a 4th segment in there, something like that. Okay, does that seem reasonable? Does that follow the pattern based on inductive reasoning, what we see in here? 1 segment, 2 segments, 3 segments, 4 segments. And write a conjecture. So we could say something like the number of segments we could say this a couple ways, is equal to the term number. Remember the numbers or figures in a sequence is called a term. So figure 1 would be the first term, has 1 segment. Figure 2, the second term, has 2 segments, that kind of thing. Okay, so that could work. We could also do some things. Some of you guys might have been looking at that as how many different regions are formed, right? Like 1, 2 regions, or 1, 2, 3, 4 regions. 1, 2, 3, 4, 5, 6. How many separate regions are formed. So it appears to be 1, 2, 4, 6, 8, 10. Might that continue forever? I don't know. Be worth checking into. Okay, but as a conjecture, it seems to fit. It seems to be reasonable. We're not going to necessarily have to prove it, but it seems like it may be the case. All right, and to get some practice for you, this will be the assignment. Okay, let's see if we can get a page number. This appears to be page 6. Okay, so you guys will end up doing page 6, numbers 10 through 14.